Now you'll see a triangle without a grid on it, but we have a bunch of angles marked on it. This is a unit circle, which we call a unit circle because the radius equals 1 unit. Okay? We're going to go ahead and label the angles on our unit circle. I'm going to put the angles right inside the circle. That's 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330. Oh, and one more, 360. So I've gone all around the circle and marked every angle that has a 30, 45, or 60 degree reference angle, as well as 0, 90, 180, and 270. Now we're going to transfer the coordinates from our other two circles that we did, the one that had the 30 and 60 degree reference angles, and then the one with the 45. And we're going to label all these coordinates. So the 30 degrees were all had a longer adjacent side than opposite side. They're all square root of 3. In quadrant 2, that would be negative square root of 3 over 2, 1/2. In quadrant 3, it's going to be both negative. Negative square root of 3 over 2, negative 1/2. In quadrant 4, at 330, it's going to be positive square root of 3 over 2, negative 1/2. So notice that in quadrant 1, x and y are both positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x and y are both negative. And in quadrant 4, x is positive, y is negative. This is going to make a difference for our sine, cosine, and tangent functions. Now let's go ahead and do our 45 degree angles. So 45, we have square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2, square root of 2 over 2 in quadrant 2. In quadrant 3, we have both negative, negative square root of 2 over 2, negative square root of 2 over 2. Quadrant 4, x is positive again, so positive square root of 2 over 2, negative square root of 2 over 2. Okay, in 60 degree now. 60, notice we don't, at 45, we went, x and y were both the same distance. Okay, we went over in the x direction, up in the y direction, same amount each time. 60, we're going to go a shorter amount in the x direction, a taller amount in the y direction. So this is 1/2 square root of 3 over 2. Second quadrant, negative 1/2 square root of 3 over 2. Third quadrant, both negative, negative 1/2, negative square root of 3 over 2. Fourth quadrant, positive 1/2, negative square root of 3 over 2. Now I want you to notice some patterns. Obviously pause the video if I've gone too fast and get caught up first. Look at the pattern, what's happening with the x and y values. Square root of 3 over 2, square root of 2 over 2. We could think of this even as square root of 1 over 2, which is why I wrote the middle one as square root of 2 over 2, because it's kind of a nice pattern with that. Notice the x values are getting smaller, and that makes sense because if we thought of these three triangles, the adjacent sides are getting shorter every time. The x, we go over more in the x for 30 than we do in 45, and more than 45 than we do in 60. Okay, so x values are getting smaller. Y values, however, are getting bigger with each of these angles. So what are the coordinates at 0? Okay, this is a unit circle. It has a radius of 1. So how far out am I going in the x direction? Hopefully you'd say 1. How far in the y direction? 0. If we go up to 90, how far out am I going in the x direction? 0. In the y direction, 1. If I go to 180, I'm going negative 1 in the x direction and 0 in the y direction. And if I am going to 270, it's 0, negative 1. Now recall what I said about the unit circle. I'm going to go down and do this. So in a unit circle, where the radius of the circle equals 1, and we draw a little section of the circle here with the x and y axis, and we put a triangle in here, and I call this angle theta. The hypotenuse is 1. The adjacent side is the x direction. The opposite side is the y direction, and that would correspond to the point xy on the unit circle. Cosine of theta is going to be x over 1, which is just x. Sine of theta is y over 1, which is just y. And tangent of theta is y over x. And y over x is the change in the y direction, which is the rise, divided by the change in x, which is the run. Rise over run is slope. So this just equals the slope of the angle. Okay, so if I know the xy coordinates, I can find sine and cosine and tangent just knowing the coordinates on the unit circle because the radius is 1. That's only because the radius is 1. Otherwise, I would be dividing by something other than 1, and this would not have the same relationship. So that means now I have a way of figuring out what is cosine of 0, what is cosine of 90, what is cosine of 180. Look up at 0. What is cosine of 0? Cosine of 0 degrees is equal to 1 because that gives me, that's the x value. Sine of 0 degrees equals 0 because that is the y value. If I go up to here, I can say cosine of 90 equals 0. Sine of 90 equals 1. I can go over to my 180 and I can say cosine of 180 equals negative 1. Sine of 180 equals 0. I can go down to 270 and I can say cosine of 270 equals 0. Sine of 270 equals negative 1. Actually, I don't like where I wrote that. I'm going to write that in a slightly different place. Make me feel better. Then I'm going to write it under here. Sine of 270 is equal to negative 1. Okay, so I can now find sine, cosine, and tangent of any angle, even if I can't draw a triangle. Now, for those of you who like to draw triangles, let me just show you something that might be helpful to kind of think about. Oops, just dropped my microphone. Okay, so if I open up another page here. So let's say I have an angle very close to 0, like this, okay? And here's my circle kind of coming out like this, all right? So right now, here's my opposite side, my adjacent side, opposite adjacent. My hypotenuse, remember, is 1, okay? So let's say this point is sliding closer and closer to 0 degrees. What's happening to the opposite side? Opposite side is getting closer to 0. As a matter of fact, at 0 degrees, the opposite side equals 0. There is no opposite side. What's happening to the adjacent side as we move closer and closer to 0 degrees? If we move this point right here closer and closer to 0 degrees, well, the adjacent side is getting closer and closer to being 1, which is exactly the same length as the hypotenuse. So at 0, the adjacent side equals 1. So it makes sense that when we do sine of 0, we get 0 over 1. When we do cosine of 0, we get 1 over 1. Now, let's think about what happens when we have an angle really close to 90. So I'm going to draw an angle really close to 90, drop down the perpendicular line. Here's my little triangle. So here's the hypotenuse equal to 1. That's kind of hard to see. Let me write that a little better. So here's the hypotenuse equal to 1 right there. Here's the opposite side. Here's the adjacent side. I'm having a little trouble writing right now. Now imagine and this is, we're on a circle, okay? And we're sliding this point closer to 90 degrees, all right? So this angle right here is pretty big, and we're making it closer and closer to 90 degrees. So what's happening to the adjacent side? The adjacent side is getting smaller. The closer this point up here gets to the very top at 90 degrees, the adjacent side is going to get smaller and smaller. The opposite side is going to get bigger and bigger until at 90 degrees. So I'm going to write here the adjacent side is getting closer to 0. And at 90 degrees, the adjacent side equals 0. So at 90 degrees, let me do it kind of the same way I did before. At 90 degrees, the adjacent side equals 0, and the opposite side is equal to the hypotenuse, which is 1. Okay, so the opposite side is going to be straight up. So that tells me that cosine of at 90 is 0 and sine of 90 is 1. So that's another way of looking at it. Okay, so the next thing we're going to do is look at this pattern, and we're going to do something with the graphs. So let's just kind of re-examine the pattern here. What's going on? So let's start with cosine. Cosine starts at 1 and goes down. Square root of 3 over 2, square root of 2 over 2, 1/2, 0. Once you get to 0, if you want to keep going, you're going to have to go into the negative numbers. So cosine is negative, 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 but it's getting a bigger number, bigger negative number, so we get to -1. And then cosine stays negative as we go around, okay, negative, 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 but the numbers are getting smaller until cosine goes to 0. And once we get to 0, it crosses back into positive numbers. So cosine is positive, negative, negative, positive. So let's kind of see what cosine is doing here. So cosine is positive because it's x. And I'm going to write that differently. Sorry. Cosine is positive because it goes with x. Here, cosine is negative because it goes with x. Here, cosine is negative because it goes with x. And here, cosine is positive because it goes with x. All right, so cosine goes positive, positive, negative, negative, and it goes to 0. It starts with the biggest it gets is 1, the smallest it gets is -1. Okay, let's look at sine. Sine is 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. It's getting bigger. Then it gets smaller, square root of 3 over 2, square root of 2 over 2, 1/2, 0. And when it gets to 0, then it has to go negative. So now we have -1/2, negative square root of 2 over 2, negative square root of 3 over 2, -1. That's the smallest for cosine, or for sine. Then negative square root of 3 over 2, negative square root of 2 over 2, -1, 0, back to 0. So positive, positive, negative, negative. Okay, so let's look at cosine here. Or sorry, sine. This whole thing of sine. I think I might have just said cosine, but I meant sine. We were just doing sine. So sine is positive because it goes with y. Y is positive here. Sine is positive because it goes with y. Y is positive in quadrant 2. Sine is positive because it goes with, sorry, it's negative because it goes with y. I was just on a roll there. It's negative because y is negative in quadrant 3. Sine is negative because y is negative in quadrant 4. Now, what do we do with tangent? Tangent is y divided by x. So for tangent, tangent is positive in quadrant 1 because it is y over x, and they're both positive. Tangent is negative in quadrant 2 because it is y over x, and y over x is a positive divided by a negative. Tangent is positive in quadrant 3 because it is a negative divided by a negative. which is a positive. So here's a positive divided by a negative. In quadrant 4, tangent is negative because it is y over x, and in this case y is negative and x is positive. So tangent goes positive, negative, positive, negative. Now this may be a repetition of what we've heard, but I want to repeat it because I want you to see the pattern. One other fun pattern that isn't a real big deal but just is fun to see is if we look at the numbers as we count from 0 all the way up to 1, we can think of 0 as the square root of 0 over 2. Then we go to 1 over 2, which we could think of as the square root of 1 over 2. Then we go to square root of 2 over 2. Then we go to square root of 3 over 2, which is here. And then we go to 1, which we could think of as the square root of 4 over 2, because that would equal 1. So notice that interesting pattern. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Just a fun pattern. Fun, yay. So I just thought that was kind of an interesting little pattern to show you as we go around the unit circle. So our next video now, we're going to talk about how this unit circle now is going to lead us into sine and cosine and tangent graphs.